Hi and welcome everyone to this Keptn Quality Gates on Keys webinar. I'm very pleased today to have Thomas with me. Hi Thomas.
Hello.
And I'm Jürgen, and we are going to present our efforts on making the Keptn Quality Gates ready to be deployed on keys. As I said earlier, please feel free to use the Q&A feature of Zoom, ask your questions, and I will forward them to Thomas whenever it fits, or I will collect them to the very end, and then I will forward it to Thomas at the end. It will also be recorded, so feel free also to rewatch it on YouTube or to share it on YouTube. We have everything we are presenting today also is available in our GitHub repository. Thomas will walk us through all this through the example, and then you can also go ahead and try it yourself. If you want to test Keptn in general, please go ahead and do so via tutorials.keptn.sh, or just learn more on keptn.sh, and also make sure to follow us on Twitter and star us on GitHub. So on Twitter, it's Keptn Project, and on GitHub, you might already know, it's github.com/Keptn/Keptn. That's our main repository. And I think without further ado, we will kick this off. So yeah, I will hand it over to Thomas. Please lead us through this webinar, and I will just jump in whenever there is some part for me.
Thank you, Jürgen. Just the next slide. Yes, today you will hear why we started this project and why we think it's a good idea to use keys for the use case of quality gates. Afterwards, we'll give you a high-level overview about Keptn Quality Gates and show you why you shouldn't miss this feature. To make this usable by you, we will show you the Keptn on keys installation, which you can try out at home, at work, in the cloud, or on almost every Linux machine. After this is done, we will wrap up and give you some information how you could help us to improve this. So, yes, Keptn is currently designed to be used on Kubernetes, and therefore we need a Kubernetes cluster to be operated. But in many cases, you will not have a Kubernetes cluster by the hand, and I think you will want to try out new software in a sandbox before installing it on your production infrastructure. I had a similar problem before, and I simply wanted to spin up a single node cluster, install Keptn, and use it in a very fast way. So I wanted to try the approach with keys. This has been packaged in a script, and the script provided is in a very early stage, and accordingly to the underlying manifest installation, experimental and only working for quality gates at the moment. Currently, this installation mechanism could help you if you want to check out the quality gate functionalities and find out how Keptn feels. At this moment, it's not intended to use this in production. So this should be a disclaimer. Then Jürgen, tell us about something about quality gates.
Sure. So as you said, for today, we are showcasing how Keptn Quality Gates are working. And for this, a very, very brief explanation what a quality gate really is, and when we are using the term quality gate, what we really mean with this. It's basically when you are deploying and when you are delivering your software to your end users, you want to make sure the quality is satisfying. And for this, you have to check with tests, you have to check the quality of your software, and you have to evaluate this. And Keptn Quality Gates basically automate a lot of this procedure. So with Keptn Quality Gates, they can reach out to different metric providers or to different data providers automatically. They will then generate the score based on a definition file, and they will come back to you with a decision that is made based on the score, which can be a fail or a pass. And based on this, you can then decide if you want to push it to production or if you want to hold it back. That's basically the Keptn Quality Gate. Keptn itself has more functionalities, but for today, we're only focusing on the quality gate. And from this, let's say, very high-level overview, let's take a look how it really
Jürgen, you are muted.
How did this happen? I muted myself. I hope that you could hear the last sentence of the last slide, but basically I just want to show you a little bit of a real life explanation of the Keptn quality gate. And for this, we are basing on core concept of site reliability engineering, namely SLIs and SLOs. So as a SLI, that's a service level indicator. You can think of this like a metric that will give you some data that you can build your decisions upon, and where you can define some criteria upon, which are your service level objectives. And for the service level objectives, you can really define the criteria which your microservice or your applications have to conform to or have to satisfy. So in this case, we can see very easy, simple 3 indicators of an error rate or the count of database calls. And we can also see how we are using these indicators in our objective file. And for example, the error rate in this case has to be smaller than 1. So smaller than 1%, the error rate has to adhere to this criteria. Otherwise, we will not assign any score to this quality gate. So we will, in total, we will not allow this artifact to go through production, or we just not assign any scores to it, any points to it. So in total, the Keptn quality gate can generate and calculate the score, and will give you then back, let's say, a recommendation if this version of the software should be passed to the next stage, let's say production or not. So in a very simple example, you can use Keptn, the Keptn CLI in this case, and later Thomas will show you this in the demo. We can just start an evaluation for the last 30 minutes for a specific microservice, and then Keptn will automatically query the SLI providers, which are Dynatrace, Prometheus, Neoload, whatever data provider you configure. It will fetch this metrics, it will evaluate the value of those metrics and give you back a total score. So it might be a total score of only 50%, which means the quality gate is not passing. In this case, we will need at least 75% to allow it to pass with a warning, or 90% to be successful. And let's say it is a total score of 90%, it would be a thumbs up, and we are good to go. And we will show in the demo both use cases where we can see a quality gate that is passing, and we can see a quality gate that is failing. So in a nutshell, the quality gate is really an automation mechanism that will evaluate the quality of your service that should move to your, let's say, production environment. So with this, I'm handing back to Thomas. I hope screen sharing is doing fine, so you can take over again. Yes.
Yes. Keptn is currently running on Micro-Kubernetes, Minikube, and many other Kubernetes distributions. So you may ask why we should use keys for running Keptn. At first, Keptn is keys is a single binary distribution. So the installation is very, very simple, and very simple to embed in a shell script, as I did in this case. Additionally, it has a very small footprint, and in my opinion, it has some many things integrated, such as an ingress, a node path provisioner, and yes, for instance, Helm controller, which would allow you to install Helm charts per manifest, which we don't use currently, but it's a funny thing in my opinion. So what will we show you now? Our demo environment consists of an GCE instance, so a simple virtual machine, which has nothing installed, I think, but a bash and I think curl. We will run a shell script which will install the keys environment, install the Keptn environment, and afterwards we will install an application in this environment, and then look how the quality gates behave that Jürgen showed us before. So let's go in medias res and start. Just a moment, I will share my shell now. Jürgen, do you see my shell?
Yes, it's working
Yes, very
fine.
fine. So currently we have two shells here. Both are on the GC instance. So the first thing I want to do is to install Keptn on keys. Keptn on keys is a single bash script which can be downloaded from GitHub. This gets piped in a bash, and we have some parameters. So we can choose which cloud provider we want to use. So like GCP, AWS, and DigitalOcean. And we say that we want Prometheus integration to be installed. So the SLI service and the Prometheus service will also get installed. So let's restart. At first, we see that the provider is GCP, which we use now. We detected this IP. This IP is very important for us because the ingress object which we will create will use this IP address and the xip.io domain. So after this step here, so starting keys and so between the namespace Keptn and after the starting keys thing, Kubernetes is already installed. So the smallest thing of our demo today, I think, is keys. And now we are already installing Keptn here. So we created some airbag objects, installed the nuts operator, and so on. Currently, we are waiting for the nuts operator to get ready. And after this gets ready, it will not take long. Will not take any longer. We're creating the data store objects, create persistent volume claims, which are use case for the node path provisioner. Yes, and create some other objects.
So it's because we already got the first questions, and thanks for the question. Please make sure to use the Q&A feature here. First question was, are you installing this on your local machine or in the VM? And I think you mentioned it in the beginning, but I just want to forward the question again.
Yes, I'm running it in a VM. So I pre-created the GC VM to have the IP addresses and so on available for the demo. But I also tried to install it on my local machine and it also worked.
Awesome. Thank you.
So after that is done, everything is installed and we get some information about our Keptn installation. So we have an API URL, we have a bridge URL, we have a bridge username, a password, and an API token. And we get the necessary commands to install the Keptn CLI, which we'll do now. So now we are installing the Keptn CLI, and afterwards we already have the command to authenticate on the Keptn API with the Keptn CLI. And as you see, we are authenticated now. Afterwards, we need some application where which you can apply our quality gates on. So we create a kubectl namespace named sockshop hardening. So
maybe just Thomas, sorry for interrupting, but maybe to pause you for a second. So what we did with the script that was running on the left-hand side of the screen was basically we already had the instance in GC, the GC instance. So in our Google Cloud, we already had the I think it's a Ubuntu virtual machine. Or CentOS.
I think it's an Ubuntu VM. Yes.
Okay, and we just applied, or Debian in this case.
Debian, yes.
And we just applied the shell script, which was installing keys on this virtual machine and Keptn and already the Prometheus integrations. So we are doing the use case of the quality gates with Prometheus as the data provider and as the data store. So we already have set this up. And now in the next phase of the demo, we're now downloading the Keptn CLI, authenticating the Keptn CLI, and now you're basically providing a sample application for us that we can work with.
Yes.
Awesome.
Yes, so I created a namespace called sockshop hardening. Now I will apply two manifests, which contain the cards database and a card service. This could be also your application. So we created a deployment, and for this use case, two services. And what you see now is that I always set keys in front of kubectl. So keys is a single binary application which also ships kubectl inside, and in some cases it might be a good idea to use this keys command for kubectl, because you may want to split to know in which environment you're operating, and this doesn't touch your current kube config. So in my case, I always use keys at the moment, but you also can switch to kubectl. So the next thing we would do now is to install Git. This I installed Git before. So now I will make a directory and change to this. So this is also there, and clone our examples directory or examples thing. So this has also been done, unfortunately. Yes, and after that, we've got everything to create a new project and to add our new service to Keptn. So we might create a project called sockshop now, and inside of this examples repository, there's a shipyard file for it. Yes, then let's apply this. And we see that we've got a new project. The project sockshop got created. We have a hardening stage as specified in the shipyard file. And yes, this is successfully finished. And afterwards,
sorry, Thomas, for interrupting. But in this case, usually we recommend that when you're creating a project with Keptn, we recommend to also set the Git upstream to have first the backup of the Git repository, but also to be able to easily take a look at all the configuration files that Keptn really manages. In this case, since it's a demo and we're only using this instance for like the next 30 minutes, we are not setting up the Git upstream. But if you want to do this in a production environment, we recommend to execute the Keptn create project command with setting a Git upstream. So you can also find all the information in the Keptn help section and also with the CLI. But it's just a reminder that we are doing this intentionally to leave out the Git upstream in this case, just for the purpose of the demo.
Okay. And after we created this project, we now can add our card service to this. So let's do it this way. So we do a Keptn create service cards in the project sockshop. And this has also been finished successfully. Yes, if you are familiar with the tutorials, you might have noticed that the installation of the Prometheus service and the Prometheus SLI service is now missing. This has also already been done during the key setup with parameter with Prometheus. Yes, at this point, we will add the SLI and the SLO resources Jürgen talked about before. So these two files are also included in the repository. So we can take a look at the SLI file in this case. Onboarding cards, SLI, config Prometheus. So we see that we use as an indicator the response time, and we use the services and so on. So we will add this to Keptn. And also add an SLO file, which is in this repository. And after we've added these two files, we could configure our monitoring our Keptn to use the Prometheus as a monitoring service. So we put in Keptn configure monitoring Prometheus for the project sockshop and for the service card. And after we hit enter, Keptn will install Prometheus for us and configure Prometheus to monitor this service. Yes, and after that, Jürgen, I think we are ready to put some load on our service, aren't we?
Exactly. So please go ahead, put some load on the service. So what we've done, I tried to summarize, and then I will just throw in a couple of questions. Thanks for all the questions that we already got in the Q&A section. So just summarizing what Thomas already did in the first, I think we're now 10 minutes or so inside the demo. We started with installing keys on a plain Ubuntu VM or Debian VM in the Google Cloud Platform. So it was a blank VM. We installed keys on it. We installed Keptn on it. With the quality gates functionality, we installed already the Prometheus integration with it. We created a project which will hold our microservices. We created also the services. We onboarded, or basically we deployed the application. So we are not using the fully fledged version of Keptn, where we are also deploying our application with Keptn. We are only using the quality gates functionality. For the sake of the demo, we also deployed the demo on the same cluster, so we don't have to switch between clusters. And now the application is up and running, and we're just doing a curl to just generate some load, and we're just adding some items in our shopping cart. So that's basically what it does at this moment. And we got a couple of questions. So is there any prerequisites needed to install keys on a VM? And I will just combine it with another question. What can you comment on the resource footprint? Because it seems that it's very low resource footprint.
Yes, the first question, what are the prerequisites? As far as I've seen, the only prerequisite to install this is a bash and curl. This was it. Currently, I didn't find any other prerequisites, and I tested this on some distributions. So this seems to be seems not to need much packages before. The second question, the resource footprint. I'm not sure how which resources I'm using now. Currently, I'm using a VM, I think. Just a minute.
So in the Git repository, we are mentioning it's one vCPU in 4 gig of RAM should be sufficient to run.
Yes, I think so. Yes, currently I think this is the configuration I've used now. In some cases, if you in this demo, it depends on your application. So if your application needs more CPUs or memory, then you will need a larger machine. But in this case, I think one CPU and 8 GB RAM should. So I have 2 CPUs and 8 gig of RAM should be sufficient. Okay, everything clear on that?
Yes, I think it was the most the questions that are related to this, and we will keep some questions for later.
Okay, so we put some load. We have put some load on the service. Let's make it clear here. And now we want to evaluate if the service behaves as we would like it. So we send a start evaluation event to our Keptn. So we say Keptn send event start evaluation for the project sock shop in the stage hardening service cards in a time frame of the last 5 minutes. And after we have done this, Keptn evaluated this the results of the monitoring of the service, and now we can fetch the evaluation results using Keptn get event evaluation done, and with the Keptn context. The Keptn context has been returned after the last send event command. So we see not very human-friendly JSON output that the result that the quality gate passed, and we get some.
We are getting the score of
we are getting
1.
this
So that's it's basically 1 of 1. So the score is 100 in total, 100% passed. Yeah, what we've seen is basically with only those 2 commands of the Keptn CLI, you can trigger the evaluation. You don't have to know where the Prometheus is living or which monitoring tool you're actually using. You just ask Keptn to trigger the evaluation for the time frame of the last 5 minutes in the past, and Keptn will give you back the Keptn context, which is needed to query the actual status of this evaluation or the actual outcome of the evaluation. That's needed because some of the monitoring tools, they need more time to process the data, and it might not be ready in the moment when you're doing the start evaluation. So in this case, you can just then, when the results are ready, you can just fetch the evaluation results. If they're not ready, Keptn will tell you, and you will try again. So you can also use this in some kind of automation. Yeah, and we are on purpose, we are using a very simple example with only 1 metric we are evaluating, because as I said, it should be a simple demo where we can just showcase how the quality gates are working.
Okay. Now we saw a positive case for a quality gate evaluation, but we will now deploy a service which is not as stable as this. So we'll update our deployment now. And now it should take a minute until it gets deployed.
While we're waiting here for the deployment to finish, there is another question. Are there any specific ports we have to open? Or is it just a port 80 and 22 on the VM, or the standard ports, or are any specific ports needed?
Currently, I've opened the ports 443 on the VM, 443 and 8080, and what was this for? I think you will need 6443 if you want to remotely manage the keys cluster. But the ports 8080 and 443 are only for my deployments in the cluster, and the 443 for the Keptn's bridge and the API. So now we've finished rolling out our new deployment, and I think we should generate the same type of load again now. So let's do it. If you watched the load generation before, you might have seen that this was a bit faster than now. Now it's getting a bit slower than, and yes.
So there might be some issues with our new version of the application, and I guess everyone that ever wrote some lines of code can relate to this, that not every version of a software is working fine. So yeah, let's find out how the Keptn quality gates will evaluate our new build of our demo microservice.
So we will also start send the start evaluation command to the Keptn quality gate to the Keptn. And now we will take a look on a bit more human-friendly view on the quality gates. So we will connect to the Keptn's bridge. So this. We will need credentials for that, which have been auto-generated during the setup. So this is the output of the setup, and afterwards we see our service in our project in the bridge, and we see everything we've done currently. So we created a service, we configured monitoring, we started one evaluation, this was the successful one, which we got the JSON output before. And we got a not so successful evaluation result, which was the result of the not so good working application. So after this evaluation, normally you would instruct your CD system to roll back to a last stable version or do some other things. If we would use Keptn for deployment of applications, Keptn could also handle the rollback of this. Yes, and as we don't have any automatic process in place, we will now do the rollback manually.
This step would not be needed for the full version of Keptn, where Keptn basically provides some blue-green deployments. But in this case, we just at one stage, we are not doing the deployments with Keptn because we just want to show the quality gates of Keptn. So we are basically rolling back to the previous version with this command Thomas is showing here. And we will do another evaluation of the quality gate to just validate if the previous version is still up and running and still doing fine. While we're waiting here, we got a couple of more questions. Thanks for all the questions. Please keep posting them in the Q&A section. Two questions are related to keys. Which container runtime is supported on keys? Is it containerd, or do you know, Thomas?
As far as I've seen, it should be containerd. Okay.
But I guess it will be you can find the answer also on keys.io. It's K3s.io. That's the official website. Also related to the installation, does the K3s setup script also support the automatic installation and setup of the Dynatrace and the Dynatrace SLI service, or is it right now only Prometheus?
Currently, I've only written this for Prometheus, but it should be no problem to add Dynatrace to that.
Okay, and then one last question. Maybe we can start doing the load generation in the background.
Yes.
To have some load on the service, and I will just forward the question from Sumit. How to set up the Prometheus via YAML and how to find the Prometheus data to put in the SLI service or in the SLI file. And I would say that's basically Keptn already provides a method to install Prometheus with Keptn configure monitoring, which will set up also a Prometheus and manage it for you. And to find out which Prometheus to put in the SLI service or in the SLI file is, I would say, it's very user related or very application related. So in our case, we are only using the response time, and we are using the response time the 50th, I think the 9th and the 95th percentile. But it's basically whatever PromQLs you want to use, you can put in the SLI file, and you would assign it a name, and then you can use this name in the SLO file and can reuse this as often as you want. But which ones you want to use, they are pretty much user defined. Keptn itself comes with some, let's say, predefined ones. And the predefined ones are based on the red metrics. So it's the response time, the error rate, and the throughput, I think is the last one. And yeah, basically that's what you can get out of the box.
Okay, so we created some load on the service now. And we have a third method to do the evaluation and getting the results of this. Therefore, we will use our API, which can be used via, which has a Swagger UI on it. So you have to browse to API Keptn and so on, and with /Swagger UI at the end. And the next thing we will need is the API token for Keptn. So the first thing after we browse to the API, let's make this a bit smaller, is the authorization. So, and afterwards, we could send an event as we did before in the CLI directly to the API. So I've pre-created some JSON thing, hopefully, and we need a type of SH Captain event start evaluation with a source and so as specified, and we need a start time. So when was a start time and an end time? So we specify which time frame we want to evaluate. So I think these are 3 hours. And we say 1430 to 1435. And we use the project sockshop, the stage hardening, the service cards, and plus test strategy as defined. And we could execute this. So what you can also see here is the curl command to which you could start on the shell to do the same thing. And we saw that the request got accepted by our API. And we did some manual step in the CLI before for the evaluation done thing. So we could also do the same thing in the API. So we will need the Keptn context for that. So this is this one. And we need the type of the cloud event, which will be SH Keptn events evaluation done. And when we execute this, we will also get the result of the evaluation, but via API. So you don't have necessarily, so you don't need to necessarily use the CLI or our bridge. You could also use curl or any other any other tool you want for that.
It's basically that we are showing 3 different ways how to take a look at the evaluation of Keptn quality gates. The first one is you can use the CLI where you can trigger the evaluation of the quality gate, and you can also get the evaluation of the quality gate via a CLI command. The second way that Thomas showed you was via the UI, via the Keptn's bridge. And the third way is if you want to have this in some automation via the API, you can also use the Keptn API to trigger the evaluation of the quality gate and also to fetch the events. Basically everything behind the scenes also uses the API. So the Keptn CLI basically makes use of the API, and also the Keptn's bridge makes use of the API. And with our Swagger documentation, we also provide you easy ways to just experiment with it and to test it. Mm-hmm. And I guess we should also be able to see what you just did also in the Keptn's bridge. So everything, all the interactions with Keptn are basically also captured in the Keptn's bridge. So also we should be able to see the last evaluation we just did by the API. We should also be able to see it in the Keptn's bridge. If you can open it up again, we should see now 3 evaluations, and we are happy to see also the last evaluation is now green again. So the rollback of our application that you initiated manually did a good job, and we are now getting back a successful evaluation of our quality gate. That's pretty cool.
Yes. So as you have seen, the keys part of the demo was very short, and we've got a ready-to-use environment with a very few or fewest steps. After we have finished our testing, we could simply remove our environment using the provided uninstalled script from keys. So this script is called keys uninstall sh and is shipped with keys. Now the keys cluster is uninstalled, the keys node is uninstalled. And when you take a look on the machine, you see that there's no keys related service anymore. So yes, it cleaned up the machine very well. And now you could, yes. And this was our demo. Yes, then let's go back to the slide set.
So I think all in all, we have seen it's very easy to install, and then you can basically walk through the already established and well-known use case of Keptn quality gates, as you would do with any other Keptn installation, if it's on keys or on some Kubernetes cluster. Yeah, I think you will come to all the lessons learned and also to the advantages of using keys.
Yes.
I was just sorry for interrupting at all.
No problem. So some things are good to know. Currently, I have tested the installation mechanism on Arch Linux, Ubuntu, Debian, CentOS, and today also on Amazon Linux. But Keys is officially supported for Ubuntu 16.04 and 18.04. Keys comes with its own kubectl, which can be used with Keys kubectl. And for reference, I've added the installation commands here in the slide set. Yes, for me, the only things to get started was a Linux machine with around 4 GB and curl. If you want to create the SLI, the Prometheus components, you need the with Prometheus flag after the installation thing. And this mechanism uses ingress controllers and zip.io as a DNS provider. So it's important to know the IP address which the installation will get. Therefore, you have multiple options. If you specify nothing, the script will try to find out an IP address using hostname-i. If you specify a provider such as GCP, AWS, or DigitalOcean, the metadata endpoint of the provider will be asked. And if you specify an IP, this one will be used. So what have I learned out of this? With this installation mechanism provided, it's very easy to install Keptn quality gates with a one-liner and to find out if it fits your use case. After you found out that it's working and you most likely need this, you can remove the setup very easily and begin to install this for a production setup as the as the introduced keys installation is currently not intended to be used on production, but it could be at some time. And this is my last slide. If some of you want to see a more production-ready version of this, feel free to edit the script with the features you would like to see, such as additional cloud providers or any other stability improvements and so on. And if you think that your improvements could have a positive impact for the community members, yes, pull requests are very welcome. And at last, if you simply want to talk to someone about your keys installation, just contact us via Slack. Thank you.
Thanks so much, Thomas. I think that's great, and I think some of the requests we already heard during the demo that people would like to see also Dynatrace integration in the script that you can basically spin up the keys environment, install Keptn, and already install the Dynatrace integrations in the Keptn installation, so you don't have to install them later on. That's, I think, something you can always do without using the flag with Prometheus. You just install Keptn on keys, and then you go ahead and just install all the external services that you would do normally. You would just install them on the Keptn installation on keys. I would assume that's working, Thomas?
Yes.
Yeah. Okay, so that's one way you can already do it. If you're coming up with some improvements, Thomas already invited you to open the PR, tell us about your improvements, tell us about the requests you would like to raise, either directly on the GitHub project. So you can go to github.com/Keptn-sandbox/Keptn on K3s. The Keptn sandbox in general holds projects that are new projects around Keptn and integrations of Keptn. So you can always, or you can find already a lot of those projects in the sandbox. And you can either write an issue there, or you can also just go to slack.keptn.sh and get in touch with the whole Keptn development team and basically discuss with them how to improve Keptn on K3s and also which use cases you might want to solve with Keptn on K3s. As Thomas said, it's a very lightweight installation of Kubernetes. So it's really developer friendly and it's very easy to get started. I think the installation today in the demo took us about 1.5 minutes, but it was not only keys, but it was keys plus Keptn already. There is another question. I will forward the question to Thomas. Would keys be able to also allow Keptn to deploy the apps? Meaning that would keys be able to run Keptn, basically the full installation of Keptn, including all other services?
Currently, we use the manifest-based installation of Keptn, which is not, which allows currently only the quality gate use case. I think at a later moment it could be that we support it, but it's not planned at the moment, I think.
But in general, keys is a full Keptn, a full Kubernetes distribution that we are using, and it proved to be very very stable. Which version of Kubernetes were you using?
I think it was 1.18.
So it's basically I think it's the most recent version of Kubernetes.
I think it was 1.18. But you with keys you have to you have three versions to choose. So you could install 1.16, 17, and 18.
Awesome. Just some feedback. Good stuff. Thanks, Rob. And another question. So it's basically with this installation that you showed, it's possible to install external services that might do the deployment. If we're not using Keptn full, that you might be able to do other services that do the deployment.
Yes, I think so.
Awesome. Yeah, if there are more questions, just post them in the Q&A section. If not, I would like to wrap it up and would like to thank everyone for joining and asking questions. Especially, I would like to thank Thomas for doing this amazing demo today. I think it was really cool to see how to set up Keptn and get it up and running within, I think it was less than 5 minutes. Really impressive. If you want to try it out, please go to this GitHub repository. Thomas has prepared all the scripts for you, so you can try it out. And please give us some feedback if you like Keptn on keys and which features you want to see there. Also, if you try it out and you run into any issues, please contact us on Slack. Also, you will find us on Twitter. It's Keptn Project. And we recently created a Google group, a mailing list for you to make it even easier to stay in touch with the Keptn team by just getting all the updates directly into your inbox. So if you go to Google Groups and search for Keptn, you will find it, or just go to keptn.sh and find all the resources there. With this, thanks so much, Thomas.
Thank you.
We will put the recording on YouTube. And I wanted to say, have a nice day, everyone. And thanks, Thomas.
Have a nice day. Bye-bye.
Bye.